Hello friends, this time I'll be showing you a video on 555 timer, and basically 555 timer works on three states: monostable, bistable and astable. This video talks about the astable mode of working of 555 timer. This state is generally used to provide continuous frequency of any clock frequency to any IC that you want. I came across this idea because I wanted to provide a frequency to an ADC. I was working on a project and I came across that I don't have any source to provide frequency. So I surfed on it and I came across that 555 timer is really best for providing frequencies to such kind of ICs, and its frequency can be varied in the circuit by just varying the resistance and capacitance. So what's a 555 timer? It's a timer. Yeah, obviously it's a timer which provides us frequencies and all the time related stuff that you want. So in astable mode, what happens? This is the output pin, third pin of this 555 timer. It provides you a frequency, a square wave frequency, a square wave of any frequency that you can adjust through these resistors and capacitors. The frequency is inversely proportional to all three of them. Like this is resistor 1, that's the resistor 2, and that's the capacitor. So accordingly, when I vary them, the frequency would also vary, and this LED over here would also blink in different manners. So this thing over here is an oscilloscope. That's a very unique feature of this Proteus simulation software. This whole thing is a Proteus simulation software, and this is an oscilloscope. It'll show me the waveform of the wave I have generated through this 555 timer. So let me switch on the simulation. You see this LED is starting, it has started blinking with certain frequency out there, and yeah, here comes the waveform. Now this is a square wave with certain frequency with all the ups and downs. Like this is high state, this is low state. So yeah, this resistor over here, this resistor is responsible for the low state of the frequency. So as soon as I decrease it, the time period for the low state also get decreased, and these two, when combined together, are responsible for the high state of the frequency. Now let me increase this. You'll see that high state of that frequency gets increased, and as soon as I increase this stuff as well, the low state of that frequency will also get increased. You see, it's increased. So this is how you can provide various frequencies through this output to any kind of IC that works on clock frequency. And I've used variable. I've used variable resistors over here. These things can also work as a variable potentiometer, obviously, because when you connect them to the ground part or something like that, they work as a potentiometer. But right now, I'm making them work as a variable resistor. So on increasing the pointer position, I'm increasing the resistance of this track, and similarly goes for this one. Now in this simulation, I've kept this capacitor a constant one, but you can also use a variable capacitor to generate more options for frequencies. So this is how a 555 timer provides the oscillation to through this output pin, which can be used for running a IC which works on clock frequencies. So let me give an example. I worked on an ADC which is an ADC 0804, and it requires 640 kilohertz frequency, I think. Yeah, that's the typical frequency it works on, and I was really worried about how to without frequency it won't work. So I surfed on net, various things came across, like you can use the interrupts of the microcontroller to provide a frequency, but that was a complicated part for me. So I came across this 555 idea, and I studied it on net, and then I thought I should share it with you guys as well. So hope you like it. Thanks.